All right, hello everyone. Today we'll be going over a few things you will need for homework 10. So what you'll be, the new thing that's coming up this homework is the t-test and the t-distribution. So we're gonna create some random data and show you what we can do with it. So here I created 10 data points that have a mean of 23. And let's say I want to test whether the mean is 25. So let's say I want to do a two-sided t-test. Now, one way to do it is very easy. We can just take the t-test function. So we just say we give it the data here. We give it our vector. We take the mean. This will be our null hypothesis that the mean is equal to 25. We'll just write the alternative as being two-sided, and then we'll use the confidence level of 0.95. Actually, by default, this is the confidence level used, and by default, it's a two-sided test. So we don't need to write this, but in case you want to change it to something else, we keep it here. So this is one way to do it. If I run this line, I'll get the result of the t-test. So I'll get the t-statistic, which is -5. I'll get the degrees of freedom, which can be calculated from the length of the vector. Because we have 10 data points, it's n-1, so it's 9. We have a p-value, which is really small. So basically, we can say that we're pretty sure that the true mean is not equal to 25 because the p-value is quite small. And we can even get a confidence interval. As you can see, 25 is not in this confidence interval, so we can be pretty sure that it's not. So it's not the true mean of the data. Now, the other way to do this is to do this by hand, and we can do that as well. It's a bit harder because we have to run everything by ourselves. But so first, let's put n to be the length of our data. So that's 10 for us. Now we need to find the standard error. That is going to be the standard deviation of our data divided by the square root of the number of observations, which we know. So we get the standard error. Then we'll take so we will need the mean of the data as well. So we'll take that. And now we can. So to do this, we take the confidence level, and to find the critical value, we'll need to use this formulas, which is, so if we need 0.95 confidence level, which corresponds to a p-value of 0.05, we would take 1 minus. Well, we'll just use this formula here to get the two-sided critical. I guess the quantile, yes, sorry, quantile. So, and then we'll get the critical value. So the critical value in our case would be 2.26. And if we look up at what we had, oh yes, actually, we'll get the critical value now. So the confidence interval will be just the margin of error around the mean. So the margin of error is, as you remember from previously, is the critical value times the standard error. And we get this on both sides of the mean. So now we can get the confidence interval here. So let's see. Okay, so the confidence interval is 22.4 to 24. So if you look here, we should have exactly the same confidence interval, which it is. So this is correct. Now to take the t-statistic, we would take the mean from the data minus the hypothesized true mean, this is 25 in our case, and divide it by the standard error. So if we do that, we should get the test statistic that's mentioned above. So it's 5.1234. And it's actually 5.123. Okay, we'll round it to 5. So that's correct as well. And now to get the p-value, we just because it's a two-tailed test, we need to multiply by 2. So it's 2 times so this is like p-norm, but instead of norm for normal, you have t for t-distribution. So we just do 2 times that and add the degrees of freedom, and you do absolute and lower tail to get the positive number. Otherwise, we can get a negative number, but it's fine. Sorry, I meant the 1 minus this number, but it doesn't matter anyway. So we get the p-value. So this is actually the same as what we had before. So if we compare with what we get from the formula, its p-value is this. So we actually have exactly what we calculated. So there's really no need to use all of this that we just did here, unless you need to calculate something very specific. So for example, if you need the margin or you need the critical value, then you should definitely follow this approach. Otherwise, you can just use this line, which gives you the same. If we want the greater, we can just change the alternative. And if we want the less, the same. So that's mostly what you'll be needing for this homework, because this is going to be a bunch of t-tests. Other than that, I think there's one more thing that probably will be useful. So let's say I have, again, some data. So let's say I have an outlier. Let's say the data looks like this. Let's say I have 10 data points that are around 0, and then we have an outlier that's 100. So if we do the t-test, there's not much we can do. So let's say that it says that it is not going to be very useful in telling us anything. So let's say that we think the mean is 5. The t-test is not going to give you a good p-value. It's not going to, if you look at the confidence interval, because the data has an outlier, the confidence interval is completely useless. So it's not of much help. But if we actually remove the data, we remove the outlier from the data, so again, we just put NA for the outlier, which is found using which.max. It gives me the index of the outlier, and we put that to NA. Then we can run another t-test, and now we can see that the confidence interval is much narrower. So we can be much more sure if the data doesn't have outliers. So now the p-value is very small. So before, we knew that our data was kind of around 0 with one outlier at 100. So if we ask for a mean of 5, it's not really, there's not much information that we can glean from it. But if we remove the outlier and then take the t-test again, we can be pretty sure that the true mean is not equal to 5, and the p-value is very low. So that's the other thing that you'll need for his homework, and that's mostly that. Are there any questions? No, you're good. Anyone else? Okay.